This is section 6.2, Parallelograms. Your I can statement for this section: I can recognize and apply properties of the sides, diagonals, and angles of parallelograms. A parallelogram is a quadrilateral with parallel opposite sides. Any of the sides of a parallelogram can be called the base. We have a few properties of parallelograms. The first one, the opposite sides of a parallelogram are congruent. So if we look at this example, we know segment AB and CD are congruent. We also know that AD and BC will be congruent. We also know that the opposite angles in a parallelogram will be congruent. So angle A and angle C are congruent, and angle B and angle D are congruent. Consecutive angles in a parallelogram are supplementary, which means they add up to 180. Consecutive means nothing separates them. So an example would be angles A and B. Angle A plus angle B will be 180 degrees. If a parallelogram has one right angle, then it has four right angles. And the diagonals of a parallelogram bisect each other. So if we draw the diagonals, we know that RQ and QT will be congruent. We also know that UQ and QS will also be congruent. Now, using that information, let's solve some problems. In this example, we know that LMNP is a parallelogram. We need to find the measure of angle PLM, the measure of angle LMN, and the measure of D. So first of all, let's find the measure of angle PLM, which is this angle right here. We know PLM is across from angle PNM, so we know those two angles should be congruent. Now PNM is made up of two different parts. It is a 42-degree angle and a 66-degree angle. So using our angle addition, we know that we can add the two pieces together and find the measure of the whole angle is 108 degrees. So if PNM is 108, then PLM will also be 108 degrees. We also need to find the measure of angle LMN. LMN is this angle up here. Now we know those two angles that are inside that blue box are consecutive angles. There is nothing that separates them. And we know that consecutive angles are supplementary, which means they add up to 180 degrees. So we have 180 degrees. We've already used 108 degrees in the first angle. So if we subtract this, that means there are 72 degrees left for angle LMN. We also had a property that told us that the opposite sides are congruent. So we know side LM will be congruent to side PN. Since PN has a length of 22, that means LM will also be 22. So we can set 2D equal to 22, and we just need to solve for D. Right now this is 2 times D, so we are going to divide both sides by 2, and we will get D will be 11. In this example, we just need to find the value of each variable that is indicated. So let's go ahead and find X first. We have an X on side QT. Because this is a parallelogram, we do know the opposite sides are congruent. So we know segment QT will be congruent to segment RS. So we can set 5X equal to 27. And now we just need to solve for X. We have 5 times X. So to get the X by itself, we will divide by 5 on both sides. And this will give us a value of X is equal to 5.4. Now let's solve for Y. Because this is a parallelogram, we do know that the diagonals will bisect each other, which means they're going to cut them into 2 equal pieces. So we do know the length from T to P will equal the length from P to R. So we can set 2y minus 5 equal to y plus 4, because they are two parts of the same diagonal, and we do know that it was bisected. Now if we subtract y from both sides, we have y minus 5 is equal to 4. We're then going to add 5 to both sides, because right now it's a negative, so we need to do the opposite. And we will get y is equal to 9. When we go to look for z, we have a z in this angle right here. So if this angle is 3z, the angle opposite of that angle, which is the angle up here, is equal to 33, and the opposite angles in a parallelogram are congruent. So we know that 3z is equal to 33. To get the z by itself, we will divide both sides by 3, and we will get z is equal to 11. For this example, we need to know what are the coordinates of the intersection of the diagonals of a parallelogram if they give you the vertices. Now, if we were to graph this, we will be able to see where it's going to be laid out. Let's just get a general idea. 2, 5 would be somewhere around here. 6, 6 would be around here. 4, 0 would be around here. And 0, negative 1 would be located around here. So if this is our shape, A, B, C, and D, we need to find the value of the intersection of the diagonals. So we have one diagonal that goes from A to C. We have another diagonal that goes from B to D. We want to see where these two values intersect. Now we do know that the diagonals are going to bisect each other, so it's going to cut it into 2 equal pieces here and 2 equal pieces here. So that point of intersection is actually the midpoint of both of the diagonals. So we can use our midpoint formula. You're just going to pick one of your diagonals. It can either be AC or it can be BD, and then we just need to find the midpoint of the diagonal. If we pick AC, remember this point is your x1, y1. The second point is your x2 and your y2. So if we plug this in, we're going to have 2 plus 4 over 2, and we have 5 plus 0 over 2. 2 plus 4 is going to give us 6. 5 plus 0 is 5. And if we reduce this, we're going to get 3 and 2.5. So our point of intersection, if you did the other diagonal, if you did B and D, you would still get that our intersection is at 3 and 2.5.